Alright, in this video I am making a new handle for one of the hand feeds on the milling machine in my shop because as I was cranking the old one, it was on its way out and it broke. It just had two prongs and they separated far enough apart from each other that the handle with the two prongs on the end would no longer grab onto the little pin that it was supposed to hold itself onto so you could hand feed the in and out part of the table towards you or away from you. Feed from the milling machine, the manual milling machine at our shop. So here I am making a new handle. I grabbed a piece of stainless steel stock out of the scrap bin, about a little over a inch in diameter, so I turn it down. It was actually more like close to inch and a quarter in diameter to start. And then I turned the OD down to 969 thousandths of an inch to get it close to the thickest part of the old handle on the milling machine, which was about 900 thousandths. But you'll see what I'll do later to go from 969 thousandths down to a little bit lower to, in fact, right around 900 thousandths. And I'll put a little center into the end of my piece of stainless steel material because I'm going to grab this material by only about 1/8 inch of it or so, and I tried to do earlier without a center in the end of it and it just popped right out of the chuck. Thankfully no one was harmed. All good there. And now I'm taking the drill chuck out of the tailstock because I'm going to put the center in, and with that center drill hole that I did in the end of my material, I'll run the center in and it will hold the material in and make sure that 1/8 inch part that I turned down won't pop out of the chuck, plus it will help my material run much more true while it's being held in the chuck as I go to turn it. So pushing the tailstock up now, and I'll lock it with the lever not seen in this shot. And then once I lock the tailstock from moving on the way up the lathe, then I can hand feed in the center into my material. Okay, so now you see it's running a little slightly out, but again, we're turning it down, so it's really no problem. And this is just for a handle. It's not like it's got to run true. It's not going to spin. It's just going to be a handle. And we got the coolant going because we're turning stainless, and this is the last good side of my tip of my turning tool, so I'm giving it the best shot it has for longevity of life while I machine various things. So got the coolant on a steady flow, steady trickle, and turning taking about 40 thousandths at a time. Not looking to go hog wild here, because again, extending the life of the tool as much as I can. I'm showing up to work early, working on this stuff before the day actually gets rolling and I gotta either go out to a job or whatnot. And then I took my 3/16 end mill. Now we're moving over to the milling machine, and I took my 3/16 end mill and I'm going through the center horizontally and vertically, if you will, on the x-axis and the y-axis if you're looking straight down at it. That way I could just put a little bit of design on the end of this handle. This is totally unnecessary for the function of the handle. I just thought it'd be cool to put a little design. So I put a plus sign indent about 1/4 of an inch deep, and then the mating piece I will press into that plus sign sized hole, and it will be made out of brass. And I'll basically just do the opposite. I'll just take out the 4 corners here of this piece of brass scrap that was just laying around. And you'll see both the stainless piece and this brass piece are both round. And usually when you grab a piece of round material in a vise, it's only going to grab on the very 2 points on either side of your round material. But I have this piece of material that I actually notched a V out in on the bandsaw, and I cleaned it up. And then that allows me to grab it on a total of 3 places here on the round material. It's being grabbed on 2 places with the V block, and then the other vise side of the vise jaw is grabbing on a third side on the round material. So it's just a little bit better of a grab, and that ensures the material won't shift around when I'm milling on it. Okay, so now I got my two pieces ready to go, and they should be able to mate up to each other. I had to touch up the corners because they were rounded on my brass piece, and to make them nice and straight, so I had to touch them up on the bandsaw. And then after that, take it over to the little sanding wheel, polish it up a little bit, but not too much. I want it to be a nice press fit. I don't want it to be loose in there. I'll put a little bit of green Loctite retaining compound just to make sure that when I press it in with the manual press, that this brass plus will mate in and will stay in there, especially because I made the brass plus slightly thicker than 1/4 of an inch, about 265 thousandths of an inch, about 15 thousandths over 1/4 of an inch, because I knew that when I went to cut it off on the bandsaw, it wasn't going to be a nice straight clean cut. And once I press it in, make sure it doesn't fall out like the Dairy Queen Blizzard test where you tip it upside down. I don't want it to shift around on me when I have it chucked in the lathe when I go to face it. I don't want there to be any issues with that brass piece just flying out of my material, so that's why it's a good, nice fit. And like I said, I notched out the end of the stainless handle with a 3/16 end mill. So I actually, when I was measuring out the 4 corners to take out of my plus sign and the brass piece of material, I actually went 5 thousandths over just so I could, touch it up on the grinding wheel to get it pretty close, and the sanding wheel, and then press her in. And I also put a nice big chamfer with my turning tool on the end of the handle. Just again, a little bit of a design going there, because at the old shop I used to work at, same coworkers, just at the old shop when I was first starting out, if they would ever make something to fix a machine in the shop, they just put a little design on it, just a little extra touch, because you're taking pride in your work and whatnot, the old school way. And now the very end of the other side of my handle that will attach to the pin and the other piece, so that the handle can swivel up and out of the way into the rest of the handle, which you'll see later. I had to machine it down to make sure it fits in the mating piece, because there's going to be a mating piece you'll see later in the video that's going to slide over this little tab right there, and there's a small pin about 1/8 of an inch thick that goes through the hole of this mating piece, and I'll have to drill 1/8 of an inch hole through my little tab on the end of my handle here. But first I'm going to mill a flat, and I'll end up milling 4 flats, just again for a little bit easier of a grab. That was my thought process. Instead of having a smooth round handle, put 4 flats. I'll still deburr it and whatnot, of course, but to get down to my 900 thousandths of an inch outside diameter like the original handle was, my thinking was put 4 flats on this 969 thousandths OD stainless handle, and each flat I take off about 30 thousandths. So it actually puts me down to 909 thousandths of outside diameter, which is plenty close enough to the original handle being 900 thousandths of an inch. 9 thousandths apart, I'll take that. And here's my 1/8 inch hole. The drill bit was struggling through stainless. That's why you always got to use plenty of cutting fluid or good oil, whatever you have, or just straight up coolant. But on this milling machine, the coolant reservoir was empty, hence my use of cutting fluid instead. Now I have the handle mocked up. It works in the function when it's extended out, so you can crank the table in and out, but I also want to be able to fold it up and out of the way when not in use, because the really big handle for the vise on this milling machine gets in the way if this handle is stuck out and ready to be cranked. So I want it to also be able to fold up and away like the old handle was able to do. But the old handle had a spring. You could actually pull the handle out from the inside housing it was mounted on, and then fold it up out of the way. But here, I don't have a spring or anything like that, so I grabbed a little piece of a magnet that I found, and I put a Sharpie mark on the end of it where I want the magnet to be drill and pressed into the my stainless handle here. And all I did was, once I put a little Sharpie mark on the end of the magnet, I just folded the handle up into it and kind of rubbed it a little bit. And that's how you see I have my mark made of where I want to drill. And I took a 191 thousandths of an inch drill bit. I believe that was a number 17 drill bit or so. And then, because I mic'd with my 0 to 1 mics, I mic'd the little magnet, and it came out to like 193 thousandths of an inch. So I figured the drill bit would wallow out the hole very slightly, maybe to 192. And sure enough, it was right on the money for a good press. I even put a drop of that green retaining compound you saw me use earlier in the video. And also for the magnet in that hole, it worked just fine. And there it is. That's the handle. This has been the Handle Time video, and I'll see you in the next machining video. I'm working on a hammer for a graduation gift for a fella. So stay tuned. More videos to come.